presentation. I'm just gonna, Amazing, right? As a point of housekeeping, we're moving fast, we're covering a lot of ground. If you have questions or comments, make a note, write them down. We're gonna end the session today with a town hall in which we can have one room-wide conversation about what we've learned, what we haven't learned, what we'd still like to learn. So that is coming on the program. But now let's pivot from education to robots. Rebecca, we're talking a lot about the promise and the peril, and you definitely come down on the promise side of AI. But I think your motivations and your history and your reason why is different from a lot of other people. So maybe talk a little bit about how you found yourself in this role, working for FedEx and managing a robot fleet.
Yeah, Dan, I talked to Dan a little bit about my background, and I'm actually very inspired by X yesterday. And so I'm going to share a little bit about my personal journey, what led me to today's role as Corporate Vice President of Advanced Technology for FedEx. I lead a group of amazing, passionate people. We focus a lot on using robotics and autonomous technologies to help shape the future of FedEx. But I have extremely humble background. So I grew up in the 70s in a village in China without running water or electricity. So it's dirt floor, oil, like wicked lamp, no technology. And I also battled dyslexia for undiagnosed. So it was very hard for me at the beginning, but I found my way to graduate as an English major from an elite Chinese university, which is Fudan, and then embrace the early 90s when China opened up to the world, and find my way to the US with 2 pieces of luggage, $100, and a scholarship to the University of Maryland, College Park. So it's amazing that in my MBA time, I actually interned at FedEx, that's in '98, as a marketing intern. And I really loved the business because to me, it's connecting people with possibilities. And for FedEx, we move a ton of those shipments. Actually today, 14.5 million, I actually want to repeat, 14.5 million daily shipments and throughout the world. So for me, that mission is amazing, to connect the world of commerce, to send beautiful flowers on special occasions, to move vaccines, and to actually even move pandas, like back and forth. So it's amazing business, a lot to learn. So I kind of grew up my career at FedEx, and I was inspired by our founder, Mr. Smith, to get into autonomous technology in 2015, so completely switching from marketing to the advanced technology space, and also fell in love with robotics. And so today I have my role. So it's a little bit like a different profile than most of the technologies here.
Yeah, we've had a lot of conversations about ChatGPT. The thing is, everybody can use ChatGPT, so they're familiar with it. But we're going to talk about robots and sort of the physical nature and the physical manifestation of all these AI technologies. Before we do that, we've got a video where we can actually show you what they look like in action. So maybe we roll that video, and then we'll come back and talk after it.
Yeah, sounds great.
So pretty cool. I have to say that video is a little triggering for me because in college, I was telling you this, I worked one night at Roadway Packaging Service loading trucks on the night shift from 11 to 6 a.m. in the morning. Absolutely exhausting and something I was very, very poor at and incredibly stressful in a weird way. I mean, it was my first day on the job. I don't think I came back for the second day.
Well, you still had an amazing career.
Yeah, it was a very brief career in packaging. But talk to us a little bit about what we saw happening there in terms of the robots and then the technology that goes into making those decisions and actually loading those trucks.
Yeah, so it's like what you, I mean, so far we hear a lot about generative AI, the ChatGPT type of technology. And as many of you know, that's one form of AI, and which I call it the language major. And what we are doing a lot on the robotics front to move physical aspect of the shipments is more like what I consider math major of the AI, and very much centered around high algorithms and math algorithms, and also the computer vision. So when we look at how, as a big corporation, we should embark on a journey about robotics, we don't start with technology, and we start very much, first of all, with the problem we're trying to solve for. And then match to say what type of technologies that can suit our needs. So in our world, robots are not new. If you look at robotics, like automotive industry started with robotics technology many decades ago. And they do very precise tasks. And for us, it's actually not very helpful because in our work environment, we have, say we have 14.5 million daily shipments. They all come in very size, shape, weight, and packaging materials. So what you see in the warehouse environment where robots can move the same size, the shape, or like standard SQU type of robots are not very helpful for our environment. So we need to extremely advanced robotics AI-driven technologies. And that's because there are 3 characteristics kind of like we have to really manage through the robotics technology. And the first is our packages are mixed. The different various size, shape, if you change all the dimensions, you just makes the robots a lot harder to work. And then you also have randomized shipments because we move shipments based on where we pick them up and deliver them. So we don't kind of stage which package should show up in front of the robots. It very much depends on what's real time coming down from sortation. And then the third one is high throughput. We don't keep inventory. We're very different than warehouses. So we have extremely short sortation windows because everyone wants your shipments to be on time. Mm-hmm. So if you put a trifecta together, the mixed shipments, real-time randomization, and also the high throughput, we all know that's an extremely difficult problems for robots to solve for. So what we see is a huge breakthrough in AI over the last actually several years, driven by 3 core technologies, which is the very advanced computer vision, because to me it's more robots can see better now, and the GPU advancement driven by everything, crypto, like gaming, so the computers can processing a lot faster, and finally the kind of very advanced AI algorithm. So those 3 converging forces are making robots a lot smarter. So what we see is not the hardware side of robotics technology, like robotics arms, it's more the brain. Mm-hmm. That's very much needed for our operations, and also those kind of truck loading as one example of the key initiatives we are working on. We target to make our team members' job a lot easier. Mm-hmm. As Dan said, it's a very physically strenuous job. So we're excited about leveraging the AI-driven robotics technologies to solve the problem.
The other thing that's it's not obvious if you haven't loaded a truck like that is that it's a very tactile sensation. Like you're picking up every package, you don't know how much it weighs when you pick it up, and that'll decide where it gets placed in the truck and how it gets stacked. And the robots have to sort of make those same decisions and process that information the same way a human would.
Yeah, absolutely. And then you're definitely, even you just did it one day, you definitely mastered it.
I did it one day when I was 20. Yeah. I definitely don't want to do it now.
And but you clearly hit 2 of the key challenges. One is the space. Because if you look at the truck, like how you stack up the kind of like space, fully utilize the cubes is a very major decision. So for humans, it's like playing Tetris. Like rolling truck is more like a combining workout with playing Tetris. So you pick up a package, depends on size and weight. You have to determine the ideal location inside the trailer. And that's the same challenge for the robots because depends on the weight. You put the heaviest stuff at the bottom. If you load it on the top, it's going to crumple the whole wall as well as cause damages. And so for robots, they have to combine the advanced computer vision as well as a sense of touch. So first of all, you needed to, for robots, that's why I said it's a combination of three forces. Technology really matters. It's the way robots see the shipments, so the dimensions and the size and shape. So they actually have generative wall building within 500 milliseconds and go through billions of combinations to see where they should place it to optimize the placement. And at the same time, it's a sense of touch, which actually needed to happen is knowing and sensing the weight of the shipment and the packaging, so you put it in just the right amount of force on that. So it's a very advanced force control mechanism that if you understand how much force to place it and where to place it, and those kind of very advanced decisions differentiate the next generation smart AI-based robots versus previously more the precision-driven. So it's counterintuitive. Precision in robotics technology is easier than imprecision.
Yeah, because you have to manage for the imprecision.
Correct.
And the unknown. And we've actually heard that come up a bunch of different times in terms of that area for play. The other key thing about these types of automation projects is that there's huge safety implications because we don't think about when we ship packages, we only see the arrival and departure. The truth of the matter is there's lots of people involved to make that happen along the way, and it's a hard job, and there are safety considerations for a company as big as FedEx. Can you talk a little bit about how you view safety and how you're putting the workers into that equation?
Yeah, so safety, at FedEx, we have a key goal, which is safety first. So in our operations, because we move a lot of packages, we have a lot of equipment, a lot of facilities. So we always view anything we introduce to our system, we have to fully test it, and it has to integrate into our operating environment, and our team members needed to know what to do with it. So that's one a design principle is the robotics operation has to be 100% safe. And the second part is we have to engage our frontline and our team members in the design. So very much it's when we do innovation, it's very hard to have an innovation and we do it in the lab and work with startups and then go to operations hey, here you go. That's a solution for you. And we learned that's not the most effective way. The most effective way is actually invite the team members who will be using it. Because, for example, how the robotics rover need to safely navigate into the trailer and how that it should navigate outside the trailer that wouldn't cause any accident, and what kind of sensors, what kind of LiDAR needs to be there. So if there's an emergency, someone was not paying attention, it needs to immediately come to a stop. And so all of those mechanisms we very much build into the design. Craig mentioned, for AI, you have to have built-in control systems, and that's very much our design principle is to actually build the safety into the design and making sure that the principle is the safety first.
It's actually, as I'm thinking back on the video is almost, it's a video of the robots, so it focuses on the robots, but in the real world, there would be people in that environment that are interacting, and therefore the process needs to be designed around them as much as the robots themselves.
Absolutely, Dan. So to us, it's not just the technology, and in order to make it applicable to an environment like ours, it's people, process, and technology. So we have the technology. We have to take into considerations the human-machine kind of interactive environment, and also the processes. What are the key control mechanisms? What are the safety procedures? What's the operating manual for those. And so all of that has to be really down into the kind of development at the beginning, not like an afterthought. It's pretty much like a key input to the design, and so that we can actually translate into advanced technologies into really business values.
We've seen loading of the truck and sort of understand how the robots can operate in a warehouse. Are there other robots or automations that FedEx is using to sort of speed up delivery of packages?
Yeah, we are looking at a lot of those kind of, we test a lot of, like, we are working on palletization, depalletization type of robots. We also looking at trailer unloading. What you see is the trailer loading, but there's also a pretty taxing part, which is you have to move all the packages out of the trailer and put on the conveyor belt for sortation, right? So the key principle when we look at it is the job is very strenuous in nature and it's less desirable by our team members. So I said at the beginning, we don't start with the technology, see which one is cool, and it's like a hammer. You go to the business and hit a nail. We view that as less effective. So for us to really generate the best value, to make our team members' jobs easier and more productive, is to listen to them and see what other jobs they actually is harder for humans to do, more strenuous in nature, and then work on those. So it's very exciting field.
And what about self-driving cars and trucks? I mean, we are all familiar with FedEx trucks running all across our cities and up to our houses. Have you experimented with any self-driving cars or automation in that space?
Yeah, some of you probably heard we actually announced in the news a couple of years ago about like with Neuro on the last mile, and also Aurora on the line haul. So we have very similar design principle is like lead by safety. And that's why in the Aurora's case, we not only team up with them, but we also team up with OEMs, because FedEx has lots of planes. As a matter of fact, we have 700 planes. And planes can actually, a lot of times, like they can fly and land, take off themselves. But we actually learned from that is you needed to have build secondary, tertiary safety procedures, even for autopilot. And that's the same principle when it comes to autonomous vehicles. And it's not just about autonomous technology from the kind of technology companies. And we also see that a huge need to involve OEMs, because redundancy in the vehicle base is critical, redundant braking, redundant steering, redundant power source, so that all of those has to be integrated to making sure the technology is actually safe to operate and have plenty of tests on the road.
What are you excited about? And you've got access to your own research labs. You see what's coming down the pike. What technologies are you excited about that you think are going to be really transformative?
I actually think AI in general, I mean, we are just at the tip of the iceberg. So coming back to your first question, I'm definitely seeing the promises. I mean, while we have to be thoughtful and responsible in managing the risk side, but overall, just the promise to unleash a lot of power to transform the way we actually can operate in the future, improve the safety, efficiency, productivity, and just like that's what I'm super excited about in the future.
Excellent. Well, I'm sure people have questions for you. We're going to save them for the town hall, which is coming up very soon. But Rebecca, thanks so much for joining us. This has been great.
Thank you so much.